So, in the last class we studied the flow control of TCP protocol. In the flow control we studied that it uses the sliding window scheme, and in the sliding window, as we know, the window size increases and decreases depending on the size of the receiver buffer. We are talking about the receiver buffer because it is a stream oriented service, and this sliding window of TCP is byte oriented. This is a very important thing. It is byte oriented. The reason behind is your segment size is not fixed. So, it has a maximum size and it can accommodate any number of bytes in between that. So, how the window is managed? So, we have something called the window management in TCP. Window management. If you have a sender process here and you have a receiver process here, you have a receiver, and we know that, let us assume that your receiver buffer is of 4000 bytes, let us say, that is an assumption, and the sender has a quite a large buffer size. Here the buffer is quite high in comparison to the receiver, but because the receiver has the buffer of 4000, so what will be the maximum window size? Definitely 4000. Now, let us say the receiver decides that the window size is 4000, fine. Now, because the sender has got a huge buffer, what it can do, let us have a timer, we will see how the sender and the receiver works by managing or how the window is handled. So, it sends the first sequence, first segment, and let us say the whole of the 4000 byte is accommodated into the segment. Let us say this is the segment 1, and all the 4000 bytes of the sender that has been generated in the application program of the sender is accommodated in segment 1. So, the content of the segment 1 will be the initial sequence number, you can say. Let us say the initial sequence is 1001 for simplicity, and it says the size of the byte inside the segment is 4000 bytes, right. It says the sequence number and it says the size of the data. So, now it goes to the receiver. So, when the segment 1 is arrived at the receiver, all the 4000 byte will occupy the buffer, agree. Now, what is the size left with the receiver buffer? 0. That means whole of the buffer of the receiver window or receiver process is now occupied with the size of the first segment or data size of the first segment. But it has to send an acknowledgement saying that I have received the segment. So, what it does? It sends an acknowledgement segment for what? Acknowledgement of which byte? The next byte. Now, the size sequence number is 1001 with a size of 4000. So, what will be the next byte expected? This is 5001. So, when it sends the acknowledgement for 5001 means it is understood that it has received all the bytes up to 5000. And the thing what it does is it declares a window size of 0, saying that I have received your data, I am expecting the next byte starting with the address 5001, but now my window size is 0, I cannot enhance the window. So, you do not send me now. So, now when this is sent to the sender understands that my earlier segment has arrived correctly without any problem. It has been acknowledged by the receiver, but the receiver does not want me to send any more data because it has declared the window size to be 0. Now, when the receiver will send again, if it can consume, let us say out of this 4000 after certain time t1, it makes 1000 bytes free. This is free and another 3000 is now still occupied because the receiver may be a slower processor, maybe something, right. So, when this 1000 bytes or 1000 byte space is made available at the receiver buffer, the receiver now can send another acknowledgement declaring the window size of availability. So, next again it says the acknowledgement is still again 5001 and now the window is equal to 1000. That means I have a free space of 1000 bytes. So, your next segment should carry maximum 1000 bytes, not as per the size of my buffer earlier which we said as the 1000. 4000. So, when this window size is declared, now the sender expands its window to another 1000 bytes, correct. So, this 1000 byte is again now encapsulated into a segment saying the sequence number as required is 5001 and the size of the segment is now 1000 bytes. This is segment 2. This is segment 2. So, that means every time the receiver announces an acknowledgement of certain size, it makes the sender or it allows the sender to send a segment of that much of size required by the receiver. And unless otherwise, now after sending this 1000 byte, again your buffer is 0, right? Buffer size, the buffer space is 0. So, it will send the window size of 0. So, as long as it gets a space of sufficient large size or required amount, it will send a non-zero window size of some window something xx which is non-zero value, then again it can send the next segment. So, this is how the window is managed between the sender and the receiver. If you remember, it is somehow similar to the flow control is a sliding window is similar to your DLL, but there you had the number of frames and you are encapsulating the data into the frames, you are sending that. But here you have to see how much space is actually free to accommodate the bytes in the receiver buffer, and accordingly that many bytes will be encapsulated into the segment and that could be sent. And the receiver has an option of sending non-zero window size to hold the sender for sending further data. That is how your window is managed between the sender and the receiver. Now, let us say let us consider a situation. Your receiver is a very slow receiver. Two options. Your receiver is a very slow receiver. What it does? Let us say the initial segment 1 has come. It occupies all 4000 bytes now. And because it is a very slow receiver, it consumes the data from its buffer very slowly. Let us say it consumes byte. 1 byte is free after some time. So, what it does? It declares a window size of 1 byte. The sender is always ready to send the data because it has huge buffer size and data is always ready. So, even if it gets a window size of 1 byte, it tries to send that 1 byte in the next segment, segment 2 of window size data size 1 byte. That means the actual size of data now being transmitted in the second segment is 1 byte. And this 1 byte data will be encapsulated into a segment, right? What is the segment size? Minimum segment size 20 bytes of header plus 1 byte of data, as we know. Now, this comes to the next layer, the IP layer, where again 20 bytes of header and this 21 size of segment will be there, right. So, what is the header size then now? Total header size 40 for how much of data? Can you say this is an efficient transmission? Just to send 1 byte of data, your overhead is 41 by 1. You are sending a chunk or a datagram of size 41 which contains only 1 byte of data. The reason behind is the receiver was a slow receiver. It could not make the free buffer at the receiver end in time, but the sender is always ready, so he has to send the data. That is what is the, now you can say this is the problem with the receiver side. Let us say the same case happens with the sender, it may also possible. Let us say sender is an user who is not able to create the data faster. He goes on typing one by one, line by line, something. So, what he creates? He creates 1 byte of data at a time. Slow processor, slow sender. So, again to send that 1 byte of data into a datagram, you take 40 bytes of total header, 1 byte of data, again the same 41 by 1. So, in both the cases, you see that your overhead is much higher than the actual data, is actually higher than the data. So, this is what this is a situation we call as the silly window syndrome. The silly window syndrome, and this syndrome can be caused by a sender or it could be caused by a receiver. So, if the syndrome is created by the sender, how it is being handled, and if the syndrome is created by the receiver, how it is being handled. So, that is what is the handling the silly window syndromes. Silly window syndrome, the syndrome due to the sender. So, as we discussed, why a syndrome can be caused by the sender? It is a slow sender. So, fills the buffer very slowly and the segment size are very less, and you are creating a, the overhead is increasing. So, to have this kind of solution for this kind of syndrome, Nogales has a solution called the Nogales algorithm or Nogales solution, you can say. What Nogales says, the first step of Nogales solution is send the first segment even with 1 byte of data as it is created, even with 1 byte of data generated by the sender. Whatever data is being created or generated by the application program at the sender side, generate the first segment and transmit to the receiver. The segment 1 will be sent to the receiver. Now, while sending to this receiver, two entities play the role. One is the network, another is the receiver who sends the acknowledgement, right. That means propagation in this direction and the propagation of the acknowledgement. So, you get almost a RTT, you get an RTT for the next segment to be generated, right, and that much of time may be sufficient to at least create another segment of maximum size. That means you are giving time to the sender buffer or the sender application program to generate the next bunch of data, at least a sizable data to be accommodated into the next segment. In the meantime, by the time the first segment is transmitted or travelled to the receiver and the acknowledgement is received. So, in the second stage what he says, send the next segment after the acknowledgement is received or a sizable amount of data is generated at the sender application program. That means the time or the time of the next segment is a function of the sender processing, sender speed, you can say, sender speed and the network performance. So, he is considering two parameters. One is the speed of the sender application, another is the network performance. If the network performance is faster, that means if the sender process is still slower than the network, propagation time, then at least some amount of data will be created and it can be generated. Other way, if the network performance is slower than the sender, then always there is a good chance that you have a good amount of data to be accommodated into the segments. But anyhow, your transmission starts with the least data, then a time factor is considered for the next segment, which is again a function of both this parameter, and your transmission continues. That is what is the solution provided by Nogales to avoid the silly window syndrome generated by the sender. And the third step is repeat the same process of step 2, repeat step 2. That means the same is valid for all the segments to be transmitted in this process. That is what is the Nogales solution. Now, coming to the syndrome that is generated by the receiver. As we discussed, this could be possible if the receiver is a slow consumer. Your buffer is filled with data, let us say that same 4000 bytes of data is filled, but this fellow consumes 1 byte at a time, byte by byte. In that case, you have very less space in the buffer size, so you send a window size of 1 byte. If you send in window size of 1 byte, the segment will continue again the 1 byte of data. So, again there is a syndrome, right. So, how this syndrome could be eliminated? For this, two solutions are there. The first one is the Clark solution. First one is the Clark solution. What Clark says, step 1 is send the acknowledgement as soon as the segment arrives, but send the window size to be 0. Send the window size to be 0 till you have enough space. That means if you have 1 byte free in the buffer, do not set that window size is 0, I mean the window size is 1. So, you go on sending the window size to be 0 till you consider a maximum size that could be accommodated into the segment. That is what was suggested by Clark. So, he says that the window size can be announced as 0 till you have enough space in the segment. And another solution for the syndrome at the receiver side is delayed acknowledgement. What this solution says, this is again for the receiver syndrome. What this solution says, if you get an segment and you do not have any space in the buffer, it is all filled with the 4000 bytes, then do not send the acknowledgement. No acknowledgement is sent till you have enough space in this. So, one says send the acknowledgement, but declare the window size 0. Another says do not send the acknowledgement till enough space has been created in the buffer. But by doing so, delayed acknowledgement, what could be a possible problem? The problem will be if you delay the acknowledgement for a longer time, the result will be timeout. So, there is always a trade off. You frequently send the non-zero window size, zero window size, hold the sender. By doing that, you are sending multiple acknowledgements. The other one, you do not send the acknowledgement, there also you are making a timeout case and there will be a retransmission, all those. But again, depending on the network scenario or the situation, the designer can decide how he can remove the syndrome. So, a syndrome generated by either the sender or the receiver, who takes care how the transmission or the window can be managed by applying this Nogales solution or Clark solution or the delayed acknowledgement process. Usually it is seen that 5 millisecond is the maximum time that in window that an acknowledgement can be delayed. Beyond that, if it is delayed, then again there may be a chances of transmission, retransmission and all those timeout, all those things. So, this is what is your how the flow control is maintained between the sender and the receiver by a sliding window technique, and how the window is managed by sending the size of the bytes, the segment number, how it is being acknowledged, a 0 window size, a non-zero window size, when it will be transmitted, how a syndrome can be eliminated by the different solutions, right. Now, coming to the next service of flow control, after this flow control, you have another service of TCP, that is called the error control. In the case of data link layer, we too had the error control solution, and for the frames, what are the cases of error control that we considered? We had a package called ARQ, and that ARQ consists of your acknowledgement, your lost data case, you had a negative acknowledgement, you had a lost data or acknowledgement I can say, then you had a timeout, you had a retransmission, and you had the duplicate discard, right. So, combining all these techniques, we say that is a mechanism completely called ARQ mechanism. Now, when talking about this, instead of data, we will talk about the segments now. Rest of the things we will see how it is handled by TCP, the segments and all, but the only difference between these two is that TCP has got no provision for NAC. So, though it is similar to the flow control, error control of the data link layer that we studied, But the only thing difference is that TCP does not have any NAC provision. That means it acknowledges to a segment if it is a valid segment. If it is not valid, then there is no acknowledgement. No acknowledgement meaning it is corrupted or it is lost or it is not received, right. So, to have the error control of the TCP, it has got the provisions like detecting the corrupted segments. You know, error control is a combination of detection and correction, right. So, it has the detecting the corrupted segment, then the lost segment, how it handles we will see that later. Then it has one more thing called the out of the order segments, handling the out of the order segments, and then you have the duplicate segments. So, how TCP handles with these kind of segments we will see. Let us assume that the sender has got 3 segments and each segment is of size let us say 200 bytes, right. So, you have the sender and you have the receiver. The sender sends segment, let us say sequence number is 1001 and the size is 200 bytes, comes to the receiver and the receiver sends the acknowledgement accordingly, acknowledgement of 1301, right, no sorry 1201 with window size of again 200 is sent, and the next one goes with let us say the segment sequence number of 1201 with the size of again another 200, and this fellow sends the acknowledgement of 1401. So, this also comes here. So, when both the acknowledgement reaches to the sender, this is understood that segment 1 is correct, segment 2 is correct. Now, let us say the third segment goes with the sequence number 1401, with size 200. When it comes here, it found that it is corrupted. How it finds it corrupted? You have a provision of checksum. You know that every segment has a field, checksum field, and by calculating the checksum, it understands that this segment is corrupted. So, when the segment is corrupted, it does not send any acknowledgement. So, no acknowledgement. And when this segment was sent, the timer was set for some time, and we saw that the acknowledgement comes within that period. When the next segment was sent, again the timer was set to this period and the acknowledgement comes for this. But when this segment is transmitted, we found that the timer expires here, but there is no acknowledgement till now, right. So, when this situation occurs at the point when the timer expires, you have to send, the sender sends again the same segment with sequence number 1401 and 200 size. So, now let us say this is in the correct form and when this is correct, the acknowledgement automatically comes with, what is the acknowledgement? Acknowledgement for 1601. So, when this is received, the sender understands that my previous segment was correct. This is how the corrupted segments are handled by the TCP. Every segment is acknowledged, and by seeing the acknowledgement, the sender understands that my previous segment has reached safe at the receiver side. Consider a lost segment case. If the let us say the third one, the segment 3, this is this segment 3, this is lost on the way. What will happen? This will not receive at the receiver, not receiving, no acknowledgement, timeout, the same process. That means your lost segment is handled in the similar way as the corrupted segment. In case of DLL, what it was doing? It was sending in NAC. Because there is no NAC, it is the absence of your acknowledgement considered. If absence of acknowledgement, either it is lost or it is corrupted. both are treated in the same way, and it has to be retransmitted, the segment has to be retransmitted. Now, the next case is the out of sequence, out of order segments. Why? When we know that it is a stream data service and every byte is acknowledged in the segment, but still there is a chance that the receiver will receive the segments in out of sequence, I mean out of order. Why? The reason behind is the underlying layer is a connectionless. So, in that case we know that the IP of the receiver side may arrive or may receive the datagrams or the packets out of sequence, and these segments are part of these datagrams, right. So, when the IP receives the segment, it sends to the buffer, I mean the TCP. So, though TCP is stream oriented and connection oriented and stream data service, but it may receive some of the segments out of sequence if the datagram follows a different path and arrives out of sequence at the receiver side. So, how the out of sequence segments are handled? Let us say the first segment is 1201 as 1001 as we received, the second one was 1201, the third one was let us say 1601, and the fourth one was 1401. This is segment 1, this is segment 2, this is segment 3, and this is segment 4, but they arrived in this order. Now, when this is received by the receiver, sends the acknowledgement, but when this is received, when this acknowledgement was gone, the acknowledgement was indicated as 1401, but it received a segment having the sequence number 1601. Can it acknowledge to this one? It will not. So, unless it receives the 1401 segment, it will not acknowledge to any segment which is out of sequence. If it receives 1401, then again it receives 1601 within the stipulated time period, then it can acknowledge, but otherwise it never acknowledges to any segment which is out of sequence. So, acknowledgement carries all the weightage or the credential for maintaining the reliability and the stream data service. That is how it does. And let us say the acknowledgement, the segment 1 was sent with 1001 and then 1201, then 1401 let us say, and 1601. The acknowledgement was sent for this was lost acknowledgement, we are talking about now the lost acknowledgement, but somehow this acknowledgement comes here, acknowledgement for 1401. Acknowledgement for 1201 is lost, but the acknowledgement for 1401 arrives at the sender. What does it mean? It indicates the previous segment was arrived safe. So, loss of acknowledgement is absolutely irrelevant for TCP. The reason behind is that because the acknowledgements are cumulative, if it receives any acknowledgement in between, it is understood that the rest of the segments has been reached the receiver safe. Fine. This is how your lost acknowledgement is handled. Now, another case is your duplicate segments. When the case will arise, when you will have a duplicate segment, acknowledgement lost, that may be the last acknowledgement which was lost, or the acknowledgement reaches late, right. That means, in any case there is a timeout for the acknowledgement. In that case, you have the retransmission from the sender to the receiver, right. But the receiver has already got, let us say the 1201 sequence number has already come to the receiver and the acknowledgement was delayed. So, again the sender sends the segment with sequence number 1201. So, it is again a duplicate packet, a duplicate segment for the receiver. So, what it does? Simply discards. That means, you have always the acknowledgement who maintains the streaming of data at the receiver side and decides when the segments should come, which segments should come, and how the segments will be in sequence or in order, so that they can be delivered to the upper layer, the application layer at the receiver side. This is how the error control is maintained in the TCP of the receiver side or the sender side. So, flow control and the error control similar to the DLL what you studied, with a slight modification, saying exactly how many bytes are there and how the bytes are treated by the segments and how they are acknowledged and how they are maintained in sequence.